Good morning, everyone. I don't know if it's morning there. It's morning here. My name is Andrew Jennings, and I'm the president of Conveyor Dynamics Incorporated. I've worked here for, I think about 16 years now, and I took over as president 5 years ago from the founder of Conveyor Dynamics, Mr. Lawrence Nordell. So this morning, I'd like to show you a technology that our team here has been developing for the last 2 years. It's something we're really excited about. We think this is going to revolutionize the way overland conveyors are built and the way the idlers on those conveyors are maintained. So we have developed a tool that I believe will allow mines all over the world to change idlers without shutting the conveyor down. You can change the idlers on a conveyor while that conveyor is running. So how about the typical procedure? What do you have to do today to change an idler? Well, first you figure out that an idler has failed, and you do that by inspecting the conveyor belt. You maybe inspect it once a day or once every 2 days. You walk the entire length of that conveyor or drive it, and you listen, you hear a failed idler roll, you tag it, you write down in your notebook, this idler has failed at this location, and then it goes on the schedule. Because if you were to change that idler right at that minute, what you would have to do, you'd have to shut the conveyor down. Then you would have to go and you'd have to lock out and tag out. To lock out and tag out, you would have to drive to the location where that lockout and tag out area is. You'd lock your conveyor out. Now, maybe this conveyor belt is really long and it has a head and tail drive or intermediate booster station, and you might have to drive to multiple locations and put multiple locks on in different places. So now you've locked the conveyor out. Then you drive to the location or walk to the place where that idler has failed, and you lift the belt. Now you're going to lift the belt with some tool that maybe you've designed yourselves on the mine or you've bought something off the shelf. But in any case, I've illustrated it here. It's just a rope that's been suspended from something above the conveyor. It picks that conveyor belt off the roll so that you can pull the old roll out and put a new roll in. Then you lower that belt back down again, and you go and remove your lock. You have to drive to where the lock is, possibly multiple places, take that lock off, and then inform the site to restart the conveyor. And that procedure, just putting your lock on something, might take an hour. And then you got to drive, etc., etc. It could take multiple hours just to change that single roll, and you're not going to do that for one roll because most of the time, a failed idle roll is not going to damage the conveyor, at least not for a while. So you have time. So your typical site is going to flag all the roll. As they're inspecting, they're going to flag failed rolls they find, and then schedule a planned outage. And they're going to do that maybe once a week, maybe once every 2 weeks. Probably not any less time than any longer than once a month. And maybe they're going to wait. They'll have 20, maybe they'll have 30, maybe 40, maybe 50 rolls they have to change in that 8-hour outage, or maybe it's 10, maybe it's 12. In any case, you're going to mobilize a whole set of teams, and everybody's going to put their locks on. They're going to go to their assigned roles, change out those roles, and then everyone will take their locks off at once. And you're going to I calculate, you're going to do this, you're going to have to do this at least once a month, a year. So I figure you're going to be having at least 100, but maybe it could be 400, as much as 400 planned downtime hours a year on longer overland conveyors. That's true for shorter conveyors too. Well, that means that, one, you've lost all that money you could have been operating during that time, but it also means there's a lot of time that there are idler rolls operating in a failed state. And sometimes those rolls do damage the conveyor. It's not without risk. So you'll see rolls like this that have been taken out, and this roll was allowed to operate in a failed state. And that roll is, the shell is completely worn away and it's turned into a cheese grater. It's scraping pieces of belt off. It's taking your bottom cover off your conveyor. And that is, if that belt wears out too soon, that is really a major expense that you have to deal with. Worse, sometimes you'll see the shell will detach from the end disc on the roll, and that cap will become a pizza cutter, and it will slice the belt, and that can be a catastrophic failure. It's unusual, but it can happen. Another thing that can happen is the grease burns off in the idle roll. You can't visually see it, but if you get out a camera, one of the temperature measuring cameras, you get an image like this, and that camera will show you that you've got occasionally you'll find an extremely hot roll. Here's a roll it's a photograph I took in Canada in the wintertime, and it was below 0 degrees, But yet you see where I'm pointing my camera, it's 100 degrees C, 99.1. And somewhere in this image, it's 129 degrees Celsius. That's extremely hot. So that's 129 degrees Celsius above ambient, which, it would be, if you are warmer, it's going to be more. And you can get rolls that are hotter than this. A roll can actually catch, it could start a fire on a conveyor belt, and that's extremely dangerous. So it would be nice if we had a practical way of changing idler rolls while the conveyor was running to avoid these situations that you see here. Conveyor Dynamics is not the only company to look at this problem. Here we have the Spindler system. This is installed in Australia. And the system is comprised of you've got a industrial robot arm, which actually removes the rolls. You can see it here. This is the blue thing here, the yellow piece here. And you've got something that lifts the belt. That's what these gray linkages here do. They pick the conveyor belt up. All of this is powered by a diesel generator, and you've got an electric cabinet that controls all of this, and the whole thing runs on a rail system, and it's totally automated. So in theory, the site says, go change this roll, and this robot goes out and does it. People are not standing there while it happens. It all happens while the conveyor is live. And you can see videos on YouTube of this. It's pretty neat looking. However, we talked to the people involved, and they said, look, this thing cost a fortune. And I think they may have taken it out from talking to them. It broke down all the time. They had a lot of issues with it, and really I think part of the problem is these robot arms are not designed to work in the environment that we are demanding they work in. They are not designed for the mine environment. They're designed for factories. They're designed to work in a nice climate-controlled environment, not the range of temperatures we see. On a mine, it can be very hot. It can be very cold. They do not want it to be dusty. They're designed to work in an environment that is clean, and this is a real issue. So the other issue with these systems is they often rely on, I'm not quite sure about this one, but they often there's a vision system that allows this arm to go and figure out where the roll is. And those vision systems have issues when it's nighttime, when it's raining, when it's snowing. They also rely on pretty tight tolerances on everything, and we don't have tight tolerances. They rely on stuff being square. It's not square on mines. They don't like things to be not level. So these are all issues with this kind of system, and it is extremely expensive to purchase this unit. I haven't talked to the people who installed this one. This is another device I found on YouTube, and these pictures I just took from a YouTube video. But the way this works, you can see you have a truck. The robot arm is mounted on the truck. So that's kind of nice because this is not tied to a particular conveyor. The mine can drive this unit and maintain multiple conveyors with one unit. So that has advantages. First, you have to lift the belt. So the rolls must be far enough apart. So here's their belt lifter. This is rotated 90 degrees and inserted between the rolls. It then rotates up and lifts the belt. Now, so the rolls have to be far enough apart for you to do that. And this robot arm needs to know where it is relative to the belt. Now, we investigated this idea. When we started when we started down this path, we were initially imagining something kind of like this. And what we found was the camera systems that you needed to go and find out where the conveyor belt is. You needed laser systems to determine whether this belt had settled or not. You needed all of this cost a huge amount, and the robot arm itself was expensive. Everything was very heavy. The robot arm needs a nice stable platform. None of this automation works if the robot arm is at an angle. It has to be level, and to make it level, you need a nice hard surface, or you need a very big platform, and that's very expensive, and you need a way of leveling it. To solve all these challenges was, when it all penciled out and we figured out the money, there was no way people were going to buy this thing. Maybe one person would, but it wasn't going to revolutionize the industry because it was. And the other thing we decided is it probably wouldn't work very well because it wasn't going to work at night very well. It wasn't going to work in the snow. It wasn't going to work when it's windy. There were going to be all these problems, and we felt that it was not going to be robust enough. It was going to be too expensive and not robust enough to be a viable product for the industry that we work in. So we came up with a design criteria. We said, okay, our machine has to be at least a tenth of what we estimate the cost of these other machines is. And we do have an idea what that Spindler machine is, and ours is less than a tenth of the cost of that thing. It has to work with minimal automation because the automation out there is just not smart enough to make it work in the environment that we have in a mine, on a mine, at all times of day, in all conditions, all weather conditions, at all temperature ranges. It was going to cost too much. So it has to be minimal automation, and we're going to use the precision of the adaptability of a human eye and human beings' tactile sense and vision abilities to to get this thing to work all the time. It has to be portable. We don't want it tied to a single conveyor like the Spindler system. A mine should buy one of these things, and they should be able to use this tool on multiple conveyors. It's got to be light. We don't want to use a big truck like the previous system you saw. We want this in a pickup truck, and we want 2 men to be able to move this system around. They should not need a forklift or any other machinery. You put it in your pickup truck, you take it out, you change the rolls, and you do it without shutting the conveyor down. And it better be safe. That's number one. Safety's number one. And it better not break. It's got to be designed for mines, not for factories, for the mining environment. We call our device the Ninja Idler Change Machine. That's because of the shape of some hooks on the thing in an American television show. Never mind, an American TV show. But this device will allow you to safely change idlers on a running conveyor. The personnel who are using our device, they're not going to have to cross over beyond the pull cords of the conveyor to use our tool. It will be able to extract the idler rolls without a human crossing those pull cords. You can stand back. However, there is a compromise, and the compromise that we made at this time is that you will need to purchase custom engineered, new patented idler frames that work with our machine. They interface with it. It will not work with the traditional idler frames that are out there. We will license those frames most likely to manufacturers all over the world. They should be widely available, but it is our frame, and this is going to be working on new conveyors. It's not going to be a retrofit solution. We don't have a retrofit story yet for our system. It is light enough for 2 people to deal with. If you were to have the complete tool assembled together, it's too heavy for 2 people. But our solution was to break the tool into a couple of pieces. Those pieces are light enough. Actually, I think a single person can pick each piece up, but we think you're probably going to want 2 people to put it together in a timely fashion. It goes together fast, less than half an hour to get it together and change a roll. And the whole thing fits in a typical pickup truck. Well, let's take a look at what this is. What am I talking about here? So I've got a little animation I'm going to try to play for you. So here's the first piece. A person puts this on this piece, and then another piece. I apologize for this animation. I built it myself, actually, and I'm an engineer. I'm not a graphic designer or anything. So this is something I just did on the weekend. Now this tool you use to first. Here's the idle belt lifting tool. Now this tool can lift banked idlers. It can lift. It doesn't matter. You can notice that we're all tied to the H-frame. So everything is the datum surface is the H-frame. We don't have to worry about if the H-frame is settled at some kind of funny angle. No problem. It can deal with it. Now we're going to hang our belt lifter off the H-frame, so all the loads will get transferred into the H-frame, and our insertion tool will then leave. Here the rolls lift, and a hydraulic cylinder lifts the belt off the rolls. Now you're seeing here, you're looking at, this is our custom idler frame, designed to interface with our extraction tool. We're going to extract the whole frame. This is a different idea. Everybody else is trying to remove an individual roll and replicate what the mine is doing. We're just going to take the entire frame out. And we will then present the frame to the maintenance personnel, and they can remove the rolls. So you remove the rolls, And this process then reverts. I didn't reverse the video, but basically this thing is it's going to, you take the roll off that's failed, you put the new roll on, you go rehang this, reverse around, go and take your extraction tool, take that away. Now this is Rev 1. We've built a prototype of this thing, and we've got a Rev 2 now that's better. So you're looking at Rev 1. Likely we will show you Rev 2 later. It's on our website here. You can see it. Sorry. Didn't mean to do that. Let me get back to the presentation. Okay. So, a couple of images just to show you the device maybe in a little bit more detail, explain what you just saw. This piece here is what we use to lift up and down, and we can get the carry and return all idlers with this, but this is our rail that moves up and down. And then we have here, you're looking at the insertion of the belt lifter device, and you'll notice there's a set of holes here that lets us deal with banked idlers. Over here, so now we lift the belt, and what happens, we go back, we have here, I've extracted the idler frame, it's going to present it to the person. So what does this look like? I showed everybody those animations. I released that animation a year ago on LinkedIn, and I got some comments from people wondering if this was vaporware and is it real. The answer is yes, it's real. Yes, we have a client. Yes, it will be installed. It's going to be installed soon. I won't say when, but here you see we've built, this is not the running conveyor, this is a test piece that we built for the client to demonstrate the concept, and you can see there's a fair bit of belt sag, and I'm afraid there's no pulleys on the end of this, no take up. This is just a piece with a belt hanging from it, and we tried to tension up the belt with a tractor, and it works as well as it works, but it's not perfect. It gets you the idea. So we went and demonstrated that yes, the belt lifter lifts the belt. It can lift something heavy. Now, obviously, this conveyor is not running, so we've thrown some idler rolls down here and messing around with it. But it will. This does work. It does extract frames. It does work. After building this prototype, we've got improvements, and there's a Rev 1 that's. You think this is cool? Rev 1's really cool. I'm not ready to show it yet. We will soon, but. It's coming soon. So hope you enjoyed this presentation, and I do expect that you're some of the first people to see what I think is going to be a revolution in the overland conveyor industry. In a few years, I think everybody is going to want this on their conveyor, and there you have it. So thank you for letting me present this. I'd like to thank our hosts here, and I'm very sorry I couldn't be there, but if you have questions, please contact our representative in Lima, Mr. Eduardo Pinto. We are looking for partners all over the world to supply elements of this. I think we'll probably manufacture the actual tool, lifting tool, and the extraction tool in-house, because there's a lot of clever pieces in here that I think we'll keep as ours. But we're not going to make conveyor idler frames. We're not a manufacturer. We're not a conveyor. We don't make commodity pieces, and I consider the frames a commodity part, and I consider these frames sort of commodity pieces. So we'll be licensing this for manufacturers all around the world to build, and we'll just keep in-house this tool here. So there's a lot of opportunity to work with us on this, and I hope that we'll be hearing from some of you. So thank you very much, and yep, hope everybody has a good conference.